Anyway. Okay, so what we will do this morning is I'm going to go through the... Yeah, did you want to ask a question? No? Okay, so what we'll do this morning is I'm going to go through the solution to Tuesday's lab. And I've got another problem, but I don't think we'll have time to do the next part of the thing today. So we'll just go through the solution to Tuesday's lab, right? So what I'm starting with here is the program that we finished with on Monday. And yeah, just a quick point about Tuesday's lab, right? So Tuesday's lab was kind of more, it takes a while to complete that exercise. But you know everything you needed to do to solve that lab, because all that lab is basically addition, subtraction, multiplication and division by various different numbers, using a for loop, declaring a variable, and then doing things with variables, right? A couple of very good tips for you all, right? First of all, two tips, right? First tip is don't start any lab by firing up processing and typing in code. I think that's a really bad way to start any lab. And in fact, from next week, I did this a couple of years ago and it worked quite well. No coding for the first hour of the lab. Okay, so no coding whatsoever. You can look at existing code and you can discuss the problem with whoever you're sitting beside. The actual code that you've got to type is generally quite short. It shouldn't take you more than 10 minutes to actually type the code. The actual challenge in these labs is working out the numbers, the variables, how things change from iteration to iteration. And you can do all of that in advance. Sometimes I think about, like, when I do Twitch stream my coding sessions, there's quite long periods where there's no code. There's just a blank screen, and you might think, what, is he going to have to make a cup of tea? No, I'm sitting on my screen and I'm thinking, if I add this to this, and then sometimes I take out my page and I draw things out, and I work things out on pen and paper before I actually ever attempt to do any coding. So I think it's quite important that you get into the habit of thinking deeply about the problem you're trying to solve. And if you don't understand the problem and you don't have a solution, then there's no point in typing code. Well, there is, to the extent that you might, there's no harm in typing code, right? There's no harm in putting stuff in and seeing what happens. But I think it's better to kind of maybe sit back a little bit and just contemplate what you need to do for a little while and then try to do it. And then the other tip I would say is I noticed a lot of people in my lab waited until the MCQ came live, attempted to solve the problem, waited for the MCQ. As soon as the MCQ came up, they did the MCQ and left. So that's okay. Again, I can't, you do whatever you like, right? But whenever I set one of those labs, it took me an hour to do that lab. And if anyone looks at my Git check-ins for duration, you see I took a good few attempts before I figured it out, before I got it right. So, these problems take a while to solve, right? And if you just kind of attempt it for an hour and then say, okay, it's too hard, I'm going to go away, then you've not achieved the learning outcomes of the lab. The learning outcomes, even if it takes you like 5 hours to complete the lab, if you took 5 hours and actually completed the lab on Monday, then I tell you what, you would have learned a lot and you would have really, really upped your programming skill. So if you don't complete the lab in the duration that you've allocated, and again, everyone agreed to do this at the start of the semester by signing a contract, that you're meant to go home and finish the lab in your own time. Right? So even if it takes you a couple of hours in the evening time to go through it, if you'd have done that, then you'd have just nailed programming, and everything subsequently you would have achieved that kind of light bulb moment of having stuck with a problem. What's the word I'm looking for here?
Eureka.
What's that? Well, you would have had that, but you would have also been, what's the word when you stick at something for a long time?
Perseverance.
Perseverance. You would have just persevered and eventually learned. It's like anything in life, okay? If you want to run a marathon, okay, you don't just go out in the morning and say, okay, I put my runners on, I'm going for a running marathon. You'd die if you did that. What you have to do is build it up over long periods of time. And also you have to be prepared to try and fail many times. You're not going to go out and run a marathon on your first day. You have to build it up slowly by slowly, and sometimes it's a matter of endurance. You stick with something for a long time, you push yourself that little bit further, and eventually you're able to run a marathon. And coding is exactly the same way. For any of these problems, the only reason I can do them, and maybe a lot of you can't do them, is because I've just done it for a longer period of time. There was a time when I couldn't code, I wouldn't have had any idea how to solve any of these problems. I just do loads of them. Every year I get better at programming because I have to teach it. You teach something to somebody else makes you really good at it. And by the way, I don't consider myself to be really good at programming, but these types of problems, I can just you add this to this and divide this and then the for loop and then that's it. Because I've just done them so many times. And you'll get good at them as well, okay? So there's two tips. Tip number one, think deeply about the problem for an hour before you attempt to write any code. Think tip number 2 is complete the lab. Take a couple of hours in the evening instead of watching the box set or doing whatever it is you're doing in the evening times or playing Call of Duty or GTA, and just say, hey, I'll code for a change. I'll tell you what, coding is way more fun in my opinion than playing computer games, and I love playing computer games. So that tells you how much fun it is. So, this is the program that we started with, okay? We finished this, and we figured out how to do this, and then we also figured out how to do the, get these things to scale to fit the height of the screen. Let's kind of start from this basis, right? And let's try and write our program from here. See, like, how would we go about, doing this program? Actually, maybe even before we start coding, let's take another look at the problem that we have to solve, right? So, let's try and get up onto the GitHub here. GitHub.com, here we go. This will work. Let's scroll down and take another look at the problem, and we'll also take a look at the kind of step-by-step sort of approach to solving this problem. Here's the first one, okay? So, first of all, let's do this step by step, right? And again, there's no point. You're not gonna come on some magical solution here with a nested for loop that's going to do everything in one go. That just doesn't happen. The only way to solve a complex problem is to break it down into smaller steps and solve each of the smaller steps. And then once you got one little bit done, then you can say, okay, that's that bit done. I'll move on and do the next bit. So looking at this here, the first thing I would have probably looked at and I said, okay, I'm going to draw a load of lines, right? So my job here, when I draw a line, is to calculate the x1 and the y1 and the x2 and the y2, because I need those for every set of lines that I want to draw. The height, or the position where these lines are going to be drawn, is going to be dependent on this array that I'm looking at. And each element is going to tell me the height of some aspect of the line. Now the first thing to observe here is how many lines are there? I'm surprised nobody has figured this out. This is the first thing I would have done, is looked at it and figured out how many lines do I need to draw. Count them. 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I count 11 lines. Maybe they're not laid out as clearly, right? Let's do it again. We've got 1 line, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 lines. Amazing that people didn't notice that. There's 11 lines, there's not 12 lines. And why is that? Because you've got one less lines than you have data. I mean, if you think of a really, if this is too complicated, then break it down into a really simple problem, right? Say I have 3 bars like this, and I want to draw a trend line from this. Well, okay, I've got a line going from here to here, and I've got a line going from here to here. So if I have 3 bars, I've got 2 lines. Does everybody see that? Because you need 2 values. You're going to draw a line from something to something else. That's the first key. All right. Does everybody see why there's 2 lines if you've got 3 pieces of data? Because you've got to link them up together. Is that okay with everybody? That's the first thing you would have observed if you'd taken the time to actually kind of analyze this problem. You've got 11 lines if you've got 12 pieces of data, because you're drawing a line from the previous one to the next one, okay? Next thing we might want to do is, like, looking at this example here. This is element number 0, 1, and 2 in my array, If I pull this thing up here again, we can think about it a little bit before we go and try and solve any problems here, right? So say this is of a value 10, this is 20, and then this is 23. There's the 3 elements in my array, okay? So I need to draw a line from this element to this element, and from this element to this element. Right? This is where I'm going to get the data to draw my lines, right? So, because I got to draw a line from 10 to 20 and from 20 to 23. There's my 2 lines that I'm drawing for my 3 pieces of data. Does that make sense with everybody? So obviously it's going to be some sort of a for loop, right? In this example here, I'm going to go from 0 to 1, from 1 to 2. Let's imagine I had a third one over here. I would do 0 to 1, 1 to 2, and then 2 to 3. It doesn't really matter what that is, like 30, 30 doesn't matter. So I got a line from there to there, a line from there to there, and a line from there to there as well. Obviously a for loop, right? The numbers, the elements, of the array that control the x and y coordinates. Well, this is going to be array element 0 here. This is going to be array element 1. So there's my first line. It draws from array element 0 to array element 1. My next line is going to be from 1 to 2. And then my final line is going to be from 2 to 3. So now I can see that I've gone 0, 1, 1, 2, 2, 3. That's how I get the elements out of the array. That's how I get the elements out of the array. Does that make sense? Can you see it? So, okay. Obviously I'm going to start at 0 and I'm going to go up as far as 3. So I'll write something like, this is what a for loop is for. To generate this sequence of numbers. 0, 1, 1, 2, 2, 3. So there's probably several ways to do this, but a simple way to do this, there's either of two ways I think is really nice, You can go for int I equals 1, semicolon, I is less than the array.length, semicolon, I plus plus. Okay, so that's going to give me these numbers, 1, 2, 3. Won't it? So the other number I need to get then is, when I get 1, I also need to get 0, because I need to draw a line from 0 to 1. When I get 2, I also need to get 1, because I've got to draw a line from 2 back to 1. So how do I get that? I just take I minus 1. So subtract 1 from I, and that gives you the element before I. So if I is 1, I minus 1 is 0. If I is 2, I minus 1 is 1. So I'm just using the, variables. Stuff that, like this is just stuff you already know. You know how to add variables to other variables, So then I can do something like, we'll say previous, It's going to be equals to I minus 1, like that. Okay, so that's one way to generate that sequence of numbers. Another way to do it would be to do it the opposite way. To say for I equals 0, I is less than array.length minus 1. In which case, what I'm going to do is generate 0, 1, 2. But I don't generate array element number 3. Okay, because I go 1 less than the number of elements in the array. And then I can go next is equals to I plus 1. So now I have something that goes from 0, 1, 2. And I also have I plus 1, which is going to go 1, 2, 3. So that's me generating my sequence of numbers. And that's just a for loop and a variable. So I presume you've done for loops and you've done variables and know how to use them. So that's how I would generate that sequence of numbers in order to generate the, to figure out which array elements I need to use in order to draw those lines. The next interesting thing to observe about this problem is the scale that everything is drawn to, right? So, I kind of figured a few different ways of doing this, and the one that I kind of liked then was basically saying, okay, let's make it fit into a range of 0 to 150. So this is pretty cool. So I need to basically fit this set of data into the range 0 to 150. That's the range of the data. And then I need to fit that into a certain range on the screen. So the problem here is like really simple as well. It's just a bit of like primary school arithmetic, right? So I have this data that's going to map into 0 up to 150. If you look at my array, the data finishes at 104. So that's why, we finished there at 104. If we draw the line across, there's a bit of blank space then at the top, okay? So I have some data that fits into a range of 0 to 150, and I want to map it into some space on the screen. So this is very simple division, right? You take this data range here, which is 150, and you just divide it into the range of data that you want it to fit into. So this is going to be like, in this case here, I've got a border at the bottom and a border at the top. Okay, I've chopped it off slightly, but you've got a bit of a border here, the same border at the top. You just take the range that you want to fit it into and you divide the data in, and that tells you how many pixels each piece of data is going to take. Now this is the same problem, like maybe we'll bring it back to really first principles here, right? If you went into a shop and you ordered, and you went and bought 20 oranges and they charged you €1 for it, and then you said, okay, maybe the next day I don't want 20 oranges, I only want 5 oranges, how much is that going to cost me? Tell me. If I go into a shop and I buy 20 oranges and it costs me €1, next day I only want to buy 5 oranges. €5? Any advance? Any other suggestions? No problems. Think about it. Work it out in paper. If you don't know how to do it on your head, work it out in paper.
25 cents.
Huh?
25 cents.
25 cents. Why? How did you work it out?
5 oranges is a quarter of 20.
Sure.
And then if 20 is €1, then...
Okay, and which is... Okay, that's one way to do it, right? If you're just looking for an algorithm that always works for every problem, or you don't have to worry about it to the quarter or whatever, that's good. I mean, that's thinking about the numbers. That's exactly what we want to do, is just think about the numbers. what did we say? 20 oranges cost €1. How much do 5 oranges cost? Huh? And how would you do that? That's exactly what you do. Yeah, very good. So I take 20 into 100, and that gives me 5. So now we know the cost of 1 orange. And then I take 5 multiplied by 5 gives me 25. So that's how I know, like, 5 oranges cost me 25. So this is the same problem here, okay? I have 150, and I need to fit it into some range of numbers. So I take the range and I divide by 150, and then I multiply every element by that, and that tells me, like, if it's 10, it's going to be whatever it is divided by or multiplied by this number. It's the exact same problem. I'm just mapping one set of numbers into another set of numbers. So if you understand how to do division and multiplication, that's all this problem is here. You know, let's write the code for these steps. Now this thing here again is just another for loop. This is a bit easier to do. This sideways one is a little bit trickier, you know, but nevertheless it's just a matter of addition, subtraction, multiplication, division, for loop. That's all we need. And then I would say this is probably what I would call a grind kind of problem. It's like bit by bit, you chip away at the problem, solve each bit, and then eventually you get the whole thing. So we'll try that, okay? We'll try it step by step. First step, right? Let us draw the data as a sort of a trend line, right? Rather than draw it. So let's get rid of this data draw bars code here. And let's call this void draw trend, okay? So we'll do the first bit, right? Let's look at draw bars first of all, just to remind ourselves how that works. Yep, there's draws. So first of all, we work out what's the width of every bar. It's going to be the width of the screen divided by the number of steps I want to take. Therefore, I equals 0, I is less than array.length. Set the stroke and fill color. Calculate the x value as being equals to I multiplied by bar width, and then draw my rectangle. Okay, so that's how the draw bars work. Let's see if we can do the same then for drawing the line thing. Okay, let's do a couple of calculations here. Let's calculate the width of every line first of all. How would we calculate the width of every line? In other words, the x difference for every line that I want to draw.
The width divided by the rate of length.
Yeah. How many lines do we want to draw? 11 lines. So instead of taking array.length, we're going to take array.length minus 1. That's going to tell me the width of every one. Okay, so let's call this, what do I call this in my solution? I call it line width, right? So line width is going to be equal to the width of the screen divided by it's called rainfall. Rainfall.length minus 1. Okay, so that gives me the width of every line. What do we need to do then? Let's not worry about the scaling. Let's just do the for loop first of all. This is definitely the right approach. We'll just do the for loop first of all. So then we go for. We'll write this both ways. We'll write it the way that's not in my solution, just for the hell of it. For int I equals 0, semicolon, I is less than rainfall dot length minus 1. Okay, so I'm going to go. I'm going to stop 1 before the last element here, right? And then let's draw the line. So, in fact, let's calculate these values. Let's be fairly explicit about this. Float x1 is going to be equals to my array, which is called rainfall, at position I, multiplied by, the rainfall, the x is going to be I multiplied by rainfall, line width. Yeah, so that gives me my x1 value. Okay, so it's just how far over I am multiplied by the width of every line. My y1 value. So this is going to be rainfall, the height of the screen, minus rainfall at position I. We won't do any scaling. We'll add the scaling in afterwards, right? And then let's calculate x2 and y2. So this is going to be equal to I plus 1 multiplied by the line width. Y1 will be the height minus rainfall at position I plus 1. So now you know what I'm doing here is like I'm kind of going for I equals 0, I is less than rainfall length minus 1. So I'm going 1 to view. So therefore I can do I plus 1, and I know I'm not going to overshoot the bounds in the array. And then let's draw our line. So then let's go line x1, comma y1, comma x2, comma y2. Alright, first step. And that's drawing the trend graph. So
should it not be y2? Not y1?
Yeah, that should of course be x1, y1, x2, y2. Sorry, this should be y2. Yeah, definitely. Thank you. So then let's change this around so that instead of going draw bars, let's go draw trend. Alrighty. So let's run the program now and see we should have hopefully got a trend line. So there we go, trend line. Why is it not filled the width of the screen? Anyone tell me?
You divided by 11 times 12, is it?
The lines are going diagonal.
No, it's nothing to do with the diagonals.
Just one length minus
Because you subtracted one from length.
Huh?
Because you subtracted one from the length of the array.
Yeah, but I'm going plus 1 on my y2 coordinate. This worked when I wrote it out.
Because you don't start.
Bar width is yeah. This worked when this worked in my solution.
The line is already length minus 1 as well.
Where's that?
Line width equals width rainfall minus 1 as well.
Yeah, it should be because I'm only drawing 11 lines now. I'm not drawing 12 lines.
Make it -2.
No. I don't want to just hack it. I would like us to think about it. Why is it not working? This works in my solution, so that's why I'm just kind of curious as to why it's not working here. Unless I've misunderstood something. You guys, what are we doing wrong here?
Would rainfall.length -1 be a bracket?
Oh, yeah, that's possibly it. Good suggestion, huh? Oh, awesome. Who said that? Gold star for you today. Well spotted. Yeah, cool. Well done, right? Yeah, that was good. Well spotted. Yeah, that's definitely it, and that's what I have here in my solution as well. Yeah, exactly what happened. Yeah. Another interesting thing here. Yeah, let's look at this solution here. It's really interesting. Look at this. A small gap right here at the end caused by something. Yeah, because it's an int, not a float. So I think to get rid of that small gap, what we need to do is make sure our calculation happens in float terms. So when I do my division like that, if I make sure I divide by a float, then that means it will use floating point numbers to do that calculation. So hopefully I'll get my graph drawn correctly. Now let's look at it now. There it goes. It goes right up to the edge now, okay? Does everybody understand what happened there? Couple of good bugs, right? Couple of good little gotchas. Most important, number 1, put this thing in brackets to make sure it doesn't do width divided by rainfall and then subtract 1 from it. And then also putting float in here as well, doing the cast. To make that calculation happen as a float, otherwise what will happen is it will truncate it. So, okay, that's the first problem. That's drawing the trend line. Next problem, let's try and get it to fit the trend line into just a smaller area on the screen. In other words, like we'll put a border at the top and the bottom, and we'll also scale it so that it fits, all of the data into the section. It scales it basically to a range of 0 up to 150. So, before we code it, I think it makes sense to go off and try, and work it out on paper first, what we need to do. Okay, so I'm going to draw this out here. Here's my screen. And now I'm going to put a border. Try and draw a straight line here. We'll try and put a border around everything, okay? And fit the graph into a smaller section on the screen like this. So, let's imagine that we have an area here which is the border. And an area here which is also the border. So the drawable area in here is going to be the height of the screen minus what? Border times 2, okay? So I take the border times 2, subtract it from the height, and that gives me this drawable range, I call it, in there, okay? Next of all, I have these data that I want to put into this range. My data is going to go from 0 up to 150, and I wanted to fit it into this range here. So in other words, if I do a 0, if I try to plot a 0, it should be right at the bottom here. If I did 150, it should be right at the top. Does everybody understand that? Yeah, so I need to fit 0 to 150 into this range here. So then I need to say, what's the thing that I need to multiply every piece of data by in order to make it fit in that range? And I call that the scale factor. Right? That's the scale factor. So the scale factor for us, what we'll do is we'll just take our drawable range, and we divide by 150. And then that tells me what I need to multiply my data by in order to get it to fit into that range. Okay, so that's the second part. Let's try and do that. Okay, so let's go float. We'll call this a vertical range. So that's going to be equal to the... let's make one other variable for the border. So the border, what's a sensible value to set the border to be? 50, 100? How about we get it to be dependent on the height of the screen? How about I say 10% of the height of the screen? I think that's a good idea. Let's go height multiplied by 0.1f. That's my border. And then I don't have to actually say it's 10 or 50. I can just calculate it. So then my vertical range is going to be HIGHT height minus border multiplied by 2.0f. We'll be very, very meticulous now about making sure that our calculations happen in floats rather than in. So that's my vertical range. And then let's go. My vertical scale is going to be equal to my vertical range divided by, why don't we just hard code this for now, okay, 150.0f. Really, that 150.0f, when I see that, that kind of offends me a little bit. Let's make it a float, and then we can change it if it's a variable. So this is going to be data. Okay, that looks better. It looks better like that, doesn't it? So I'm taking 150 is the range of data that I have, and then my scale is going to be the vertical range over the data range. So that tells me how much each piece of data is worth in terms of pixels. So then I change how I calculate y2. So first of all, another interesting thing here, when I'm calculating y1 and y2 now, I'm not calculating it from the bottom of the screen, not from the height. I need to calculate it from the height minus the border. Isn't that right? Because now I'm not drawing it from the bottom of the screen. I'm going to take the height minus the border. There are probably nicer ways to do this, right? But this is going to just work for me. Then I multiply that by the vertical scale. So it's just, all we're doing is adding, subtracting, multiplying, and dividing. And yeah, again, to make our graphs go upwards, we subtract from some point down at the bottom of the screen. We just, so that you see now, my graph, instead of starting at the bottom of the screen, so I don't take height minus the value, I take height minus the border, which is this point here, and then I subtract, the scaled value of this thing, and that's going to give me the point of where I'm going to draw the line from. Okay, so let's see how that works. Height minus the border. I think that will work, right? Let's try it now and see what happens. Yeah, cool. So now it looks like it's actually scaling that, you know, that data a little bit better, and it's fitting into a range on the screen. Of course, the next problem we might think about is getting it to fill the data, or, you know, to fit the data horizontally. Can you figure out how to do that? Think about it yourselves for a second and see if you can figure out how you would get it to, you know, to fit the data horizontally. What would we need to change? Yeah, the starting and the ending position, of course, but everything needs to be squashed up a little bit. Because I need to basically put the border either side here as well. So, you know, thinking about what needs to be changed here. Obviously, how I'm calculating x1 and y2, x1 and x2 is going to change. The other thing that's going to change is the line width, because my line widths are going to be smaller, aren't they? So instead of calculating my line width as being the width of the screen divided by the number of elements, my line width is going to be, let's rearrange this a little bit. Let's take the border and put it up here. Because now I need my line width to take the border into consideration. So I will take width minus the... Okay, let's make another float for this. Let's call this horizontal range. It's going to be equals to the width of the screen minus the border multiplied by 2.0f. And then when I'm calculating my line width now, I use the horizontal range. Okay. And then also, instead of just taking I plus the line width, I need to also add in the border. Okay, and let's see, does that work? Yeah, cool. So now it's squashed it into a little bit of area. Now, does everybody understand what I did there? Just instead of calculating the line width is based on the width of the screen, I just took the width of the screen minus the two borders, squishing my lines into a smaller space on the screen. And yeah, then of course, because I need to move everything over by the border, so I just add the border to the x and y, x1 and x2 values that I have calculated. You might find a nicer way to do it, okay? Is that okay with everybody? Anybody want to ask me any questions? It's good if you don't understand anything, and maybe ask me the question now, because I don't mind explaining things if people want me to go over anything again. This is a slightly, I suppose, like I say, this is a sort of a grunt way of solving this problem. We just take each little small problem, work out what numbers we need to solve, and do each little bit of the problem separately. There's no magic for this. It's just literally adding, subtracting, dividing, multiplying, and then doing things inside the for loop. Let's put in some axes. Let's put in the horizontal axis, because this is kind of easy enough to do, okay? The horizontal axis is the same thing. In fact, we can probably do, let's do the lines for the horizontal axis first of all. Actually, let's just make everything nicely colored. Let's go stroke 0, 255, and 255, so that we get a blue color. There's blue, and let's make a black background. Okay, and then let's do our lines in grey, okay? We'll do these as separate loops, even though we could probably put some of them inside. The horizontal one I could use this same loop to do, but we'll do it in a separate loop so you can see how everything fits together. Let's do the horizontal ones first, okay? So, for the horizontal ones, it's pretty much the same as this. I need to do something at every calculated x coordinate. In fact, let's just do one line first of all for the horizontal bar. So we'll go over border, down the height minus the border, and then we will go over the width minus the border, and down the height minus the border. You know, again, this is not something you learn off as such. You know, this is just, like I say, it's just a process. And we're just like, if you want to learn one thing out of this lab, it's just to break this problem down into small chunks and solve each bit separately. Okay, so there's that line there. We might want to make that grey, so let's make it grey. How do we make it grey? We could say that's maybe stroke 100 will do it, right? So we've got a grey scale there. And we might as well do the horizontal and the vertical line here, because they're more or less similar enough, okay? So then, for the vertical line, I'm going to go over the border, down the height minus the border, and then we'll go over the border again, and down the border. Go. So I got these two lines drawn here, you know, just using the border to control the x and y parameters. And now let's do the horizontal axis. I think we might just leave it at the horizontal axis. The vertical axis is, you know, more or less just the same kind of iteration. Let's do the horizontal axis. Horizontal axis, you can do it in lots of ways, right? There's a few things we need to do. Number one, we need to put a little tick, you know, a little small line at every data point, and then underneath that we need to print some text. So let's go. We need to do this 12 times. We have 11 lines, but we actually put 12 markers and 12, you know, because you go January, February, March, April, May, June, July, August, September, October, November, December. So this time we're going to go up as far as rainfall.length. Now let's calculate our x coordinate here, okay? So our x coordinate is going to be equals to, again, the border plus I multiplied by, we can use line width as well. So that gives us our x coordinate. The y coordinate. It's going to be equals to the height minus the border. And then if I want to do a little tick, I need to decide, okay, you know, how big my tick is going to be. So let's say float tick is going to be equals to the border multiplied by 0.1. So we'd say we take up 10% of the border to draw the tick, and then let's draw the line. So now we're going to go over x, down y, over x for the other x2 coordinate, and we can take y, we want to go plus the tick. I think that should do it. So I'm just calculating some small number which I add to the y value, and then hopefully I'll get my ticks. Yay, there we go. Where's it gone? There you go. Yeah, can you see the little grey ticks? So again, there's nothing fancy about that. That's just iterating through a for loop, multiplying one number by another number to calculate the x coordinate. And then, you know, the little tick thing, I just take the border multiplied by 10. You could use a hard-coded number of 5 if you wanted. But I think if you make it scales, you know, make it a percentage of the border, it makes it scale on different screen sizes, right? So if I scaled up the window size, it would be bigger. And then let's put some text in. So to do the text, I have the x and y coordinates. I just need to put the number I, sorry, not the number I, we actually have the data thing, don't we? We have the month names, I call it month names, don't I? Months at position I. The x coordinate is going to be over the x value that I previously calculated. The y coordinate, I'm thinking maybe a good place to put this would be halfway between the bottom border and the bottom of the screen. So if you just calculate that as being the y plus border multiplied by 0.5. So that's halfway into the border. Now at the moment I'm going to print the full, you know, January, February, March. So you can see the text is too long and it's not aligned properly. So there's a couple of things we can do here. Number one, we haven't done much on strings in this class, right? But I did mention that you could look up this method, how to get a substring from a string. So I always want to get 3 characters, the first 3 characters out of that string. So just dot substring, and I put a link to this. You can look up why this method works. You pass in 0 and 3, and that will start at character number 0, end at character number 3. So it's how you extract information from a string. You know, previously in C you would have done this using array notation, or you would have used pointers or whatever to get stuff out of the string. This is how it works in Java. Okay, so now I get Jan, Feb, but you can see it's not aligned correctly. So I'm wondering now, is there any way I can make this text align better so that the January is actually, you know, halfway over this, and February is halfway over this, and March is halfway over this? It turns out that there's one simple method of doing that in processing, and that's to use text align. So you call text align, and then you pass in center. Center, center. So that's the horizontal and the vertical alignment. Cool. So now everything is lined up. You know, see my text now has aligned with the tick marks that I made. Okay, so the vertical axis is kind of the same sort of principle, you know. I'm just going to print the numbers from 0 to 150, do my ticks in the same way. So we're nearly out of time, so I don't know if we've got time to do that. But if you didn't manage to complete the vertical axis in the lab on Tuesday, then that's your homework for Monday. Alright, so if you can do it yourselves, you know, using this approach and what we've learned in the class today, you should be able to draw the vertical axis and the little tick marks and put in the values. Same sort of technique, you know, just taking the space, dividing it into equal segments, working out the numbers, and that's pretty much it. Okay, I think we should probably finish at that for today. Okay, if anybody wants to ask me any questions, now's your chance. You might have often heard the expression, how do you eat an elephant? You eat it a little bit at a time. So the same with this problem as well. You can't solve the entire thing. You just solve little bits of the problem bit by bit. Right? Once you've one bit solved, then you go, that's the next bit, okay, move on. And that's the way to do these problems where you've got multiple steps, okay?